Hi there, I'm Matthew Best. I'm a data scientist, and this is my project, Fake News, Examining Misinformation and Its Spread. Just a quick roadmap to get us started here. I'll briefly describe the data set, then we'll examine the different shades of fake news and the motivations for its spread. Then we'll analyze various machine learning techniques that were applied, and finally, discuss those results and the next steps for the project. So to begin, the project had a data set that contained 26,000 articles, where the text was in one field and a real and fake designation was in another. Distribution of the data was uniform with an equal amount of real and fake documents present. Visualizing the data with a word cloud gives us a quick snapshot of what the two corpuses are discussing. There's a lot of similarities here, and we can immediately understand that they're highly political and focused domestically. So, what is misinformation? What is disinformation? And where is it coming from? Claire Wardle from First Draft Media has identified 7 different shades and flavors of misinformation that range from benign, like satire and parody, to malignant, like fabricated content. When we look at some of the URLs used by some of these fake websites, you can see that they're intentionally trying to deceive by using URLs like Channel 18 News and Channel 24 News when there's no news sources active. Now that we've looked at the types and flavors of fake news, let's take a look at some of the motivations. Elliot Higgins and Claire Wardle have provided 8 different motivations. I want to point out 2 things really quickly. One is that social media is largely responsible for the spread of this disinformation, as noted by the graphic there in the center. And if we focus on the right side, which are Claire Wardle's 4 Ps, I believe she's the most accurate, targeting on partisanship, profit, power, and propaganda as the main motivations for fake news. We have 2 outcomes with fake news. If it's deemed to be dangerous and or misleading, it can be shut down and or seized by the FBI, the Department of Justice. This is actually the landing page for a website that was hosting one of the most shared news stories in 2019 about President Trump's grandfather being a KKK member. This website was actually hosted along with 27 other domains that were controlled by the Iranian military, and it was shared at a minimum 156,000 times. As far as our data set, the worst offenders all came from the same publication, and their combined number of misleading articles represents nearly 5% of the entire corpus of fake documents examined. They all come from Breitbart Media. Let's examine some of the machine learning algorithms and see how they did. The question I set out to answer was, can a bag of words and a TD-IDF approach to NLP detect fake news? 3 algorithms were applied: multinomial naive Bayes, linear SVM, and then a passive aggressive classifier. These were chosen because first, multinomial naive Bayes focuses on frequency. SVM works for high dimensionality data, and a passive aggressive classifier updates as data flows through the algorithm rather than in batches. With a little bit of tuning, I was able to improve the performance of SVM to 89%. This is a confusion matrix of that testing. The top left and bottom right-hand corners are identifying correctly identified real and fake news articles. What we want to focus on are the white areas, which are miscategorizations. In the bottom left, we have a type 1 error, which is a false positive, suspecting a real article to be fake, where a type 2 error in the top right-hand corner is a false negative, accepting fake news as real. I knew that with tuning, we wanted to decrease the type 2 error, which would be accepting fake news as real, although both misclassifications are fairly detrimental in this problem. So a little bit of tuning, type 2 and type 1 errors were both improved, albeit slightly. Examining another model, for example, the multinomial naive Bayes, provides a much better type 2 accuracy, however, does poorly when identifying all of the real news articles. So what are the next steps for this project? First would be to verify the model's performance and address overfitting, because as it stands, it's not doing great on unseen data. Second thing would be to improve the data set, perhaps incorporating documents from the Associated Press, or maybe The Onion, to complicate things further. And finally, incorporating more sophisticated techniques like LSTM and BERT. Thank you all for your time, and I'd love to answer any questions or comments you guys have for me. Thanks so much.